Okay, hello everyone, it's Mr. Morrissey. Today is Sequences in Series Introduction. Remember, you can pause the video at any time. We're going to do 5 problems, and they'll be broken into 2 parts. So here's, you can read the notes, which you should have printed out from the internet. Read the introduction on Sequences in Series. So if you haven't done that, why don't you pause the video, read it over, and then come back to us. Alright, so we're looking to find the first 6 terms of f of n equals negative 3 to the n minus 1. Well, let's see, the first term is going to be looks like the first term is 1. Let's find the second term. We're just plugging in 2 in for n. The second term in this sequence is negative 3. Let's find the third term. Nine. Fourth term. You can see we're alternating here, positive, negative, positive, positive, negative, negative. So the next one you know is going to be positive. Without doing the work, you can see the pattern. This will be 81. And the sixth term, it's got to be negative. And 81 times 3 is 243. So here's a sequence of numbers: 1, negative 3, 9, negative 27, 81, negative 243. Okay, let's go to the next one. Remember, you can pause at any time. So write a rule for negative 1, negative 8, negative 27, negative 64. So on the notes it says writing a rule means writing a general formula for any term. So a sub n equals, well, it looks like all the terms are negative, so possibly there's going to be a negative on the outside of this equation. And then let's break down these terms. So this looks like, well, here this is 2 to the third. This is 3 to the third. I'm sort of ignoring the negatives. This is 4 to the third. And this is 1 to the third. So it looks like we could write a general rule as negative n cubed. If you were to plug in 1, you'd get negative 1. If you were to plug in n equals 2, 2 cubed is 8, times negative 1 is negative 8. Let's try number 3. It says write the series using sigma notation. If you remember from the notes, sigma notation uses the Greek letter sigma. And it looks like here 25 is our first number, and then it looks like we're increasing by increments of 25. So this part here is the index. This is all explained in the notes, so just go look at the notes if you haven't seen this. If we start with I equals 1, it would mean you take 1 and plug it into 25i, you'd get 25. If you take 2, the next number, the next integer, and plug into 25, 25 times 2 is 50. It looks like the top value, the upper limit is going to be 10. So this is the sigma notation, and just to be absolutely sure, it would mean if you take 1 and plug it in for I here, you'd get 25. Sigma notation means sums. So if I was 2, you'd say plus 50. If I was 3, 3 times 25 is 75. Plus, dot, 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 plus, the last number is the upper index here, so that's 10. 10 times 25 is 250. Okay. We are going to stop there, take a break, and then we will come back to question 4 and question 5.